गुड मॉर्निंग स्टूडेंट्स. अर्जुन, आवाज क्लियर येतोय का? अर्जुन,
गुड मॉर्निंग सर.
गुड मॉर्निंग. आवाज क्लियर येतोय का? आवाज
येतोय सर.
परीक्षेचं काहीतरी ग्रुपवर आलेलं आहे दिसतंय, मॅडमने टाकलंय ना?
हो
40 मार्काचा काहीतरी पेपर आहे वाटतं तुमचं ना?
35.
35 मार्काचा पेपर आहे. बर. आणि कसा होणार आहे काय सांगणार आहेत ना?
हा ते नाही सांगितलं अजून.
हा, तर ते आता एक दोन रिएक्शन आपले थर्मोडायनामिकचे राहिलेले आहेत. एक शेवटचा पार्ट संपवू आपण आणि मग डिस्कशन घेऊ. तर हे स्टँडर्ड इंथल्पीज आपण बघत होतो, लक्षात घ्या. Before this, standard enthalpies of formation, standard means it is denoted with H naught, remember. H naught, it is the standard enthalpies which are calculated at standard rate. And which are the standard rate? The temperature is, see, these are the standard rates, means the temperature is 298 Kelvin, the pressure is 1 bar, and the concentration of the solution is 1 molar concentration. This is called a standard rate. So the enthalpy is determined as standard rate. It is called as standard enthalpies. This standard enthalpy of formation we already discussed in the last reaction. Again, we will take a quick revision. Standard enthalpy of formation. It is denoted with delta R H naught. Standard enthalpy of formation. It is given, which is defined as standard enthalpy of formation of a compound is the enthalpy change that accompanies a reaction in which 1 mole of pure compound in its standard state it is formed from its elements. Means these are the carbon graphite and 2 molecules of hydrogen. These are the elements, they react and the compound is formed. It is called as standard enthalpy of formation, in which minus 74.8 kilojoule per mole. This is the enthalpy change. Minus means this amount of heat is released here. This is called as standard enthalpy of formation. Generally, we calculate the standard enthalpy of reaction by using the sum of all the standard enthalpies of the products minus a summation of all the standard enthalpies of the reactants. Later we will discuss about these numericals, but I want to complete these two parts, 7 and 8. It is standard enthalpy of combustion. Combustion, it is denoted with small c, delta H naught C. It is called as standard enthalpy of combustion. As the name suggests, combustion is there. So the definition, it is given, the standard enthalpy of combustion of a substance is the standard enthalpy change accompanying a reaction in which actually the definition starts from here. The remaining part is same for all the definition, in which 1 mole of the substance in its standard state is completely oxidized. This is the definition. Means in which 1 mole of substance in its standard rates is completely oxidized. In this example, one example is given in which C2H2. All the students are familiar with this C2H2. This is ethene. When it is get uh, undergoes combustion, when ethene undergoes combustion, it is 5 divided by 2 O2. It gives twice CO2 gas plus H2O liquid. Means the carbon dioxide gas is evolved and water is formed in liquid state. And this delta H naught C actually, this should be delta H naught C. Standard enthalpy of combustion is minus 1300 kilojoule. This much amount of energy is liberated. This is called as standard enthalpy of combustion, which is measured at standard rates. And the last part of this chapter is bond enthalpy. Bond enthalpy means amount of energy changes when the bond is broken. It is called as bond enthalpy or bond energy. This definition, actually all the definitions are same. The enthalpy change required. See here. The enthalpy means amount of energy change required for to break particular covalent bond in 1 mole of gaseous molecule to produce gaseous atoms or radicals. It is called as bond enthalpy. Here radicals are also given because in some cases uh, when the bonds are broken, free radicals are formed. This mechanism is introduced in halogen derivatives, free radical mechanism. But we are not interested in that mechanism. We are interested in bond enthalpy means energy change, the enthalpy change or energy change required to break a particular covalent bond. See this example, by this example, the concept will be clear what is meant by bond enthalpy. Breaking of HCl bond represented as, see here reactants, HCl gas is given because in the definition we have to consider 1 mole of gaseous molecule. So HCl gaseous already it is taken. So this HCl molecule will be broken like this: H gas plus Cl gas. This bond, covalent bond is broken, and this much amount of energy change is there. This is the enthalpy of formation, 431.9 kilojoule, and this is a enthalpy change during it is bond enthalpy delta H naught. It is nothing but standard bond enthalpy. It is given 431.9 kilojoule per mole. See here, this much amount of energy it is absorbed or required. This much amount of energy is required to break this HCl bond. It is this is a enthalpy, bond enthalpy, and this is a enthalpy of formation. See, both the enthalpies are same, but it is only per mole. There are also average bond enthalpies in polyatomic molecules. Means by example you can understand what is mean by average bond enthalpy. Say in case of water molecule, in case of polyatomic molecules, each covalent bond has its own bond enthalpy. So in case of water molecule H2O, there are two OH bonds. Although there are two OH bonds, these are identical, but they have the different bond enthalpies. First one, what is happening? H2O gas. See, one bond is broken here. One OH plus H, and see the bond enthalpy. It is 499 kilojoule. Means first OH and H bond is broken here. This H2O contains two. At the center, oxygen is there, and it is a V-type molecule. Two hydrogens are there. So first one, OH and H bond is broken and this much amount of energy changes are given, 499 kilojoule. Then this second OH, this OH bond is broken. Oxygen and hydrogen will be separated in gaseous state, and see the energy changes. It is a 428 kilojoule. Means though the bonds are same, OH bonds are same, but the enthalpy changes are different. So uh, the enthalpy of the bond enthalpy or bond energy of a reaction, it is calculated by the, we have to do the addition of these two steps and divided by 2. So it will be H2O gaseous gives twice H plus O. This is, see, this is a addition 927 kilojoule. For breaking up two OH bonds, enthalpy change is 927 kilojoules. This is a total bond enthalpy. This is the total bond enthalpy, but we have to calculate the average bond enthalpy. So the average bond enthalpy, it is given 927 divided by 2. It is 463.5. This is a average bond enthalpy. So this example, particular example is given. Though the bonds are same, but their bond enthalpies are different. So 927 kilojoule, it is the total bond enthalpy. It is divided by 2. So the answer is 463.5 kilojoule, or it can be denoted as bond enthalpy of OH bonds, in which OH bonds are broken. It is 463 kilojoule per mole. So this much amount of energy changes uh, when the OH bond is broken. So it is called as, this is possible in case of many steps. If the 2 steps, 3 steps are there, then such type of average bond enthalpy is considered here, 463.5 kilojoule per mole. Then this is a reaction enthalpy from bond enthalpy. This is a new topic introduced in the thermodynamics. This is given for solving the numericals. This will be required when we have to calculate the particular bond enthalpy. Remember this formula only. This formula and this formula is completely different. This is a uh, standard enthalpy of formation. We have to use this formula. Products minus reactants. See, products minus reactants, but this formula is different. This is a reactant bonds minus product bonds. In the textbook, there is a mistake. This word is remaining. Bond word is remaining. So the students get confused. Actually, these are the two different formulas. When we have to calculate standard enthalpy of formation, we have to use this formula, products minus reactants. And when we have to calculate particular bond enthalpy, we have to use this formula where this N indicates the number of moles of the reactant and the product respectively. So this formula we have to use when we have to calculate particular bond enthalpy only. And this formula we have to use when we have to calculate standard enthalpies of the reaction, remember. So by in the numericals, this concept will be clear. So one example is given here, H2 plus I2 gives twice HI. So the enthalpy is given in this reaction. See what is the formula? Reactant bonds. So delta H naught, HH bond is broken here. See, reactant, in the reactant H2 is given. So the enthalpy of HH bond plus enthalpy of this II bond minus 2, because the number of moles are considered here, 2, 2. 2 into enthalpy of this HI bond. So this formula it is given here, reactant bonds minus product bonds. In the numerical, this concept will be clear. But before numericals, this Hess law of constant heat summation. Remember this Hess law, it is asked for 2 marks for the examination. Very, very important. Make a mark there. This Hess law, purposefully it is not deleted because the question will be there on this Hess law. Explain the Hess's law, or it is also called as Hess law of constant heat summation. So if it is asked for 2 marks, we have to write the statement and this example. So we will discuss first what is the statement of the Hess law. Hess law states that overall enthalpy change for a reaction. Overall means total. Total enthalpy change for a reaction is equal to the sum of enthalpy changes of the individual steps. Say in this example, overall enthalpy change for a reaction. This is overall enthalpy, means it is a total enthalpy for a reaction is equal to sum of enthalpy changes of the individual steps. If any reaction it is taken in this example, there are 2 steps. First one, this is a change in enthalpy. The second step, this is a change in enthalpy. So Hess law states that the overall enthalpy change of a reaction is the sum of enthalpy changes of the individual steps. If the reaction is taken completed in 3 steps, 4 steps, so we have to calculate the overall enthalpy by the addition of all the steps. 1 step, second step, third step, fourth step. But in this particular example, there are 2 steps. So we considered this is the enthalpy change in the first step. This is the enthalpy change in the second step. And this is a average enthalpy. So we will discuss this. Application is given. Hess law has been used to calculate enthalpy changes of the reactions whose enthalpies are not known experimentally. So to determine the overall enthalpy of a reaction, reactant and products in the individual steps are added or subtracted like algebraic equations or entities. Consider synthesis of ammonia. We are considering this example, synthesis of ammonia. In the first steps, the hydrogen gaseous reacts with nitrogen gaseous. It gives N2H4, and this is a enthalpy change. Means this much amount of energy is absorbed, 95.4 kilojoule. So in the first step, uh, this is a change in enthalpy. In the second step, N2H4 again reacts with hydrogen and it gives twice NH3. Finally, we get here ammonia molecule, and this enthalpy change is different. In this step, amount of energy is released, minus sign indicates this much amount of energy is released, minus 167 point, 187.6 kilojoule. So this is the enthalpy change in the first step. This is the enthalpy change in the second step, and this is a overall enthalpy. Overall enthalpy means we have to do the addition of these 2 steps, thrice H2, because this is a 2H2 and this is 1H2. It becomes thrice H2 plus N2. N2 is written. This N2H4, this N2H4, it is cancelled, and directly we get here 2 molecules of ammonia. And we have to do the addition of these 2 steps by the, this is minus, this is plus, so we get minus 92.2 kilojoule. Now, this is a Hess law of constant heat summation. uh, in another way we can describe this Hess law, means the path is not important in case of Hess law. If A gives product B, and if the reaction takes place in several steps, first step, second step, third step, so the final enthalpy is become the addition of the first step, second step, and the third step. This is called as Hess law of constant heat summation. Constant word is used because the overall enthalpy, it is a constant. Though the reaction takes place in several steps, the constant, the overall enthalpy remains constant. So the remaining part of this chapter, it is for non-evaluative, means this part I want to show. This spontaneous process, then energy and entropy. This completely entropy part, it is deleted. It is actually very interesting part. Those students who want to uh, face the competitive examinations, for these students, this part is very important, and this is very easy. By this diagram also we can understand. In case of solid state, this is liquid state. In gaseous state, entropy means randomness. We can see here, in case of gaseous state, this randomness increases. In case of solid state, this is highly ordered state. See, this is a perfectly arranged. No randomness is there, no disorder is there. So as the randomness increases, entropy also increases. Randomness, it is called as entropy. So by this diagram also we can understand what is mean by the entropy. But unfortunately this part will be not asked for the board exam this year, but all the notes are given to you. This is an expression for entropy and spontaneity. This spontaneity is also a very interesting process. What is meant by spontaneous process? Means a process which occurs naturally without any external force or without any external influence. Such processes are called as spontaneous processes. Means water coming from top to bottom, it is spontaneous process. But when we have to lift the water from lower side to upper side, we have to use the motor. So external force we have to apply there. This is a not example of spontaneous process. Means which is a spontaneous process which occurs naturally without any external force. This is a non-evaluative. Completely the part is non-evaluative. Second law of thermodynamics is a non-evaluative. Gibbs energy is non-evaluative. Means most of the part, because this chapter is so big, so 25% syllabus is reduced from this Gibbs energy. All this part is non-evaluative. The numericals on the spontaneous process are also non-evaluative. So only up to the Hess law, it is for your exam, remember. Up to the Hess law. Again I am coming to the Hess law. Is standard enthalpies and Hess law. So we will discuss about the numericals on the standard enthalpies of combustion, standard enthalpies of formation, and the Hess law. Then we will move to the discussion part. So such type of numeric, this is 2 marks numerical and this is a 3 marks numerical. Calculate standard enthalpy of reaction. See, such type of reaction is given, will be given for the examination. Calculate the standard word is used, means we have to calculate here delta H naught of the reaction. See, delta H naught of the reaction. One reaction is given, C2H6 gaseous, and whatever the reaction, we have to write the reaction as it is, and these values are given. So we already having this formula, delta H naught of the sum of the delta H naught of the products minus reactants. So we have to put the values only. Before putting the values, say there are 4 uh, molecules of CO2. So here it is written 4 into delta H naught formation of CO2 plus 6 into 6, because in the product 6 water molecules are there. So 6 into delta H naught formation of H2O minus, now we have to take the products are completed. Now we have to take the reactants. So 2 molecules of C2H6 here plus 7 molecules of O2, and all the values are given here. we have to calculate which value is not given here. See, first we have to put the values of CO2. CO2 value is given here minus 393.5 plus 6 into H2O. H2O value is given 285.8 kilojoule per mole. So this value uh, it is substituted here minus 2. Now minus 2 into C2H6. C2H6 value is given 84.9 kilojoule, and this enthalpy change of formation of oxygen, it is considered as zero. See, it is taken, it is zero. So by doing the mathematical calculations, we will get this value minus 3119 kilojoule. This value is a standard enthalpy of a reaction. So just it is a addition, only we have to put the values. So this is a 2 marks numerical and this is a 3 marks numerical. Calculate the standard enthalpy of combustion here. Combustion, it is asked of CH4. So if the CH4 is undergoes combustion, we have to write this reaction. For writing this reaction, 1 mark is kept. And by for putting the values, we will get here 2 marks. So if such type of numerical it is asked, calculate the standard enthalpy of combustion. Here, combustion of CH4, we have to first write this reaction. When CH4 means the methane undergoes combustion, it gives carbon dioxide plus water. So CH4 plus twice O2, it gives CO2 gaseous plus twice H2O. We have to balance the equation. We have to balance. For writing this equation, 1 mark is kept because other steps are very easy. Because the same formula we have to use here, standard enthalpy of combustion. It is, see again, it is the sum of standard enthalpies of the products minus reactants. So in this reaction, the products are CO2. So in the equation, CO2 is written plus 2 into standard enthalpies of water, it is written minus reactants. See, this CH4, it is the reactants, and 2 molecules of oxygens, it is which standard enthalpy is considered as zero. So by putting the values in this equation, we already in the numerical, these values are given. Standard enthalpy is of formation of CO2, it is given 1 into, because why it is 1? Because only one molecule is there. One molecule of CO2 is there, so 1 is taken. If it is not taken, it is considered as 1. So minus 393.5, it is a standard enthalpy of formation of CO2 plus 2 into minus 285.8. This is the value of standard enthalpies of formation of water. This is already given. So put this value in this equation minus CH4. Its value is also given minus 74.8. It is one molecule, so one is written here, and plus 2 into 0 because standard enthalpies of formation of oxygen is 0. Then by doing the calculations, we get here standard enthalpy of combustion of this methane molecule is minus 890.3 kilojoule. See, such type of very easy examples will be asked for the examination. All the values are given. Only this formula is very important. Standard enthalpy of formation, it is the sum of standard enthalpies of the products minus reactants. Only remember this formula, products minus reactants. But also I want to take another example in which the bond enthalpy, when the bond enthalpy is there, this formula is reverse, reactant bonds minus product bonds. See, these two formulas are different. These two formulas are different. Here we have to calculate. See the numerical, the enthalpy change of the following reaction is given. One reaction, methane plus Cl2, it forms CH3Cl, methyl chloride plus HCl. And the standard enthalpy of the reaction, it is given minus 104 kilojoule. The bond enthalpy is also given. This is CH bond enthalpy, means energy changes when CH bond is broken, Cl bond is broken, and this HCl bond is broken. These enthalpies are given per mole. Calculate the CCl bond enthalpy. Means we have to calculate when the CCl bond is broken. So for this, we already having this formula, delta H naught of the reactant bonds. Now see this reactant bonds we have to take 4 CH bonds. Here 4 CH bonds are there. So 4 into standard enthalpy of CH bond plus ClCl bond. This ClCl bond minus 3 into CH, because 3 CH bonds are there and 1 CCl bond is there. See carefully. Here 3 CH bonds are there and 1 CCl bond. We have to calculate this enthalpy. CCl. We have to calculate this CCl bond enthalpy. So 3 CH bonds and SCl. Standard enthalpy of SCl. Then see 4CH, 3CH, 4 minus 3, it will be 1. So it is written here delta H of 1CH plus delta H naught Cl, it is written, then CCl, and remaining is SCl. Now put the values, all the values are given 1 into 414, because this is a standard bond enthalpy of CH is given 414, and this is a ClCl, it is given 243. This is not given, this is we have to calculate this value. So as it is written minus 1 into 431. So, and also the standard enthalpy of formation is given. So by this step is very important in this numerical. If this step is correct, then the remaining part is mathematical calculation only. We can find out finally delta H naught, it is 333 kilojoule per mole. So the same numericals cannot be asked for the exam, but they can change these values only. Instead of this reaction, they will give the different reaction, but the pattern of the numericals will be same. Actually, the numericals in this thermodynamics, these are very easy. Most of the difficult part is deleted. Gives energy, spontaneity, energy and spontaneity, entropy, second law of thermodynamics. So this part is deleted. Whatever the numericals I have taken and whatever the numericals I have given in this slide, go through these numericals, we will get the full marks. So this chapter is thermodynamics completed. Once again, I want to tell you what is the important part in this thermodynamics, because this is one of the biggest chapter in the physical chemistry. This relation is very important. Already I discussed all the all the important points during the explanation. This is very important. This maximum work done. 10 वेळा हे घरी लिहून बघायचं. तुम्हाला मी अनम्यूट करतो, 1 मिनिट थांबा. सगळ्यांना अनम्यूट केलेले आहे. जर कोणाला काही विचारायचं असले तर विचारा. हे 3 मार्कासाठी खूप महत्वाचं एक्सप्रेशन आहे, त्या दिवशीच सांगितले मी. त्याच्यानंतर हे न्यूमरिकल्स पुस्तकातले जरी विचारणार नसतील तरी फक्त व्हॅल्यूज बदलून विचारतील, लक्षात घ्या. ॲज इट इज न्यूमरिकल विचारणार नाहीत. म्हणजे इथं मला थोडंसं एक्सप्लेन करतो मी. आता इथं बघा, इथं 2 मोल्स दिलेले, तिथं मोल्स बदलतील, 3 मोल्स करतील, हे व्हॉल्यूम बदलतील, व्हॉल्यूम बदललं, मोल्स बदललं की आन्सर बदलतं, लक्षात घ्या. पण फॉर्म्युला तेच आहे. त्याच्यानंतर मॅक्सिमम वर्क डन कसं ओळखायचं मी शिकवलं होतं. वेन द आयडियल गॅस एक्सपांडेड आयसोथर्मली अँड रिव्हर्सिबली जर असेल तर तिथं मॅक्सिमम डब्ल्यू मॅक्स असतं. आपण इथं एक एक्झाम्पल दाखवलं होतं मी. इथं बघा, हा 2 मोल्स ऑफ आयडियल गॅस एक्सपांडेड आयसोथर्मली अँड रिव्हर्सिबली, हे 2 वर्ड असतील, आयसोथर्मली अँड रिव्हर्सिबली. डायरेक्ट मॅक्सिमम वर्क डनचा फॉर्म्युला वापरायचा. आणि जर हे रिव्हर्सिबली वर्ड नसेल तर प्रेशर व्हॉल्यूम वर्क असतं, लक्षात घ्या. इथं हे न्यूमरिकल दिलेलं इथं, हा हे न्यूमरिकल बघा. इथं काय दिलंय, 3 moles ऑफ एन आयडियल गॅस एक्सपांडेड आयसोथर्मली. इथं रिव्हर्सिबली वर्ड वापरलेला नाहीये, त्याच्यामुळे आपल्याला हे इक्वेशन वापरायचे, W इज इक्वल टू मायनस पी एक्सटर्नल इंटू डेल्टा व्ही. हे पण एक्सप्रेशन परीक्षेला येतं, हे करून ठेवा. हे हे एवढ्याच स्टेप्स दिलेले आहेत मी, रिमेंबर फॉर द एक्झामिनेशन. हे एवढ्या स्टेप्स फक्त तुम्हाला लक्षात ठेवायचे आहेत. याच्यावरनं एक्सप्रेशन, बाकीचं हे वर्डिंग तुम्हाला स्वतःच्या शब्दात तुम्ही कसंही लिहू शकता. ही डायग्रॅम काढणं एक्सपेक्टेड आहे. देन the sign conventions, it is asked for MCQ purpose. This is very important. This is not asked for the exam. This हे एक्झाम्पल्स आहेत, हे विचारत नाही डिकम्पोजिशन वगैरे. त्याच्यानंतर हे पण विचारणार नाही काय याच्यावरचं. हा, ह्या प्रोसेसेस सांगितल्या होत्या मी, आयसोबारिक प्रोसेस, फर्स्ट लॉ ऑफ थर्मोडायनामिक्स, टाइप्स ऑफ प्रोसेसेस. त्याच्यानंतर हे इंटेन्सिव्ह प्रॉपर्टी आणि एक्सटेन्सिव्ह प्रॉपर्टी खूप महत्वाचं आहे, व्हेरी व्हेरी इम्पॉर्टंट. हे परीक्षेला विचारतात. व्हेरी आय एम पी, हे व्हेरी आय एम पी याला करून ठेवा. स्टेट फंक्शन्स MCQ ला विचारतात, हे करून घ्या. विच आर द स्टेट फंक्शन्स अँड विच आर द पाथ फंक्शन्स, हे 1 मार्काला विचारतात. त्याच्यानंतर ह्या प्रोसेसेस करून ठेवा सगळ्या, आयसोथर्मल, ॲडियाबॅटिक, आयसोबारिक. हे फीचर्सची काही गरज नाहीये. त्याच्यानंतर हे विचारत नाहीत. साइन कन्व्हेन्शन विचारतात, हे इम्पॉर्टंट आहे. हा, व्हॉट इज मीन बाय फ्री एक्सपान्शन असं विचारतील. What is mean by free expansion? Expansion, when the expansion is free, there is no any opposing force. It is called as free expansion. When the free expansion is there, there is no any work done. कारण जर अपोजिंग फोर्स नसेल तर वर्क होणार नाही. त्याच्यानंतर हे खूप महत्वाचं आहे, हे एक्सप्रेशन म्हणतोय मी, एक्सप्रेशन फॉर मॅक्सिमम वर्क. This is very 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 IMP. These two minus 2.303 nRT log to the base 10 V2 upon V1 and P1 upon P2. हे एक्सप्रेशन विचारतील. डिराईव्ह असं पण विचारतील, डिराईव्ह दिस minus 2.303 nRT log to the base 10. मुलांना कळत नाही, लक्षात घ्या, कारण तिथे W मॅक्स, मॅक्सिमम वर्क डन हा शब्द वापरत नाहीत कधी कधी. डायरेक्ट असं विचारतील, डिराईव्ह दिस इक्वेशन अँड दे विल गिव्ह दिस इक्वेशन. त्याचे न्यूमरिकल्स करून ठेवा मॅक्सिमम वर्क डनचे. त्याच्यानंतर इंटरनल एनर्जीचं काय विचारतात सांगतो मी. हे न्यूमरिक एक्झाम्पल्स, याच्यावरती न्यूमरिकल विचारतात. इंटरनल एनर्जीवर थेरी कधी विचारत नाही. स्टेटमेंट्स फर्स्ट लॉचे विचारतील, फर्स्ट लॉ ऑफ थर्मोडायनामिक्स. त्याच्यानंतर हे मॅथमॅटिकल एक्सप्रेशन खूप महत्वाचे, वेगवेगळ्या प्रोसेसेसचं करून ठेवा, त्याचे न्यूमरिकल्स करून ठेवा. आणि एन्थाल्पीज, हे रिलेशन पाठ करून ठेवायचं, रिलेशन बिटवीन डेल्टा एच अँड डेल्टा यू. वेळ संपत आलेली आहे, तर कुणाला जर काय विचारायचं असेल तर मला फोन करा किंवा मेसेज करा. परत उद्याच्या लेक्चरमध्ये मी एक्सप्लेन करतो की तुम्हाला आता कुठून अभ्यास सुरू करायचा आहे, कुठल्या चॅप्टर पासून. ऑर्गॅनिक केमिस्ट्री आधी सुरू करा, हॅलोजन डेरिव्हेटिव्ह, अल्कोहोल्स, त्याच्यानंतर अल्डिहाइड्स, सोपे सोपे चॅप्टर संपून टाका. त्याच्यानंतर आपलं पॉलिमर्स घ्या, सोपे म्हणजे तो जो फ्लो मध्ये सगळे चॅप्टर संपून जातील. आणि जर कुणाला काही